In the last video, I discussed about confidence interval of mean, proportion, and variance or standard deviation. Okay, so in this video, I'm going to talk about the hypothesis testing. So you have seen these kind of things for one sample test in your elementary statistics class. So I'm reviewing that first. I will focus on the p-value method, okay, not the critical value or the traditional method. Although I will show you one example of both method, but all the other examples I will do using R, which uses the p-value method. All right. So statistical hypothesis is a claim or statement about a property of a population parameter. Hypothesis test is a procedure for testing a claim about a property of population. So methods, there are traditional method, p-value method, and confidence interval method. So we discussed a little bit in the confidence interval in the last video about how do we, whether that the if the confidence interval includes the population parameter, then so basically that's the relation. Okay, we do not reject the null hypothesis. If it falls outside, then we reject the null hypothesis. That's the idea. Okay, if the population parameter falls in the confidence interval, then we do not reject the null hypothesis, otherwise we reject. So I will show you one slide about that. But first of all, when you test a hypothesis about mean or proportion or variance or any other type of hypothesis, the very first thing you will do is you will write the null hypothesis. We denote by H sub 0, and then we write the alternative hypothesis. We denote by H sub 1, or sometimes we denote by H sub A. Okay, that is the alternative hypothesis. Okay, that's the first thing we do. And the number 2 step is writing the test value, test statistic, test value or test statistic. Okay, so on that, if you are testing for mean or proportion or variance or any other variables, you will have the different formula for the test value or the test statistic. Okay, and number 3 you will do is the there are 2 ways for the number 3. One is the traditional method, another is the p-value method. Okay, p-value method, you find out the p-value or you find out the critical value. That is another. Okay, this is alternative way. So this is alternative way is the critical value method, or we call traditional method. Okay, so that's what we do now. And then number 4 is depending on the p-value or the result from 3. If p-value is less than alpha, we reject the null hypothesis. Okay, if p-value is greater than alpha, we do not reject the null hypothesis. Similarly, if the critical value, so from the critical value, we will find out the critical region. Okay, the region right of the critical value or the region left of the critical value is called critical region. So how do I know? So if it is a right tail test, then the right side of the critical value is the critical region. If it is left tail test, left side of the critical value is the critical region. And if it is two tail test, we will say it both left side and right side. Okay, so the left side and the right end and the left end will be the critical region. So if the test statistic fall in the critical region, we reject the null hypothesis, otherwise we do not. Okay, and then we write down the summary based on whether we accept or reject or don't reject. Okay, so usually we use the word reject, then accept, or we do not accept the null hypothesis. Okay, so we use the word, we either reject the null hypothesis or we do not reject the null hypothesis. That's the wording that we use. Okay, so that is the step 4, and step 5 is the summary. So you can combine that in the step 4 for the step 5. Okay, let us do an example. So testing for mean. So what does it say? So what are the assumptions? If you are testing for mean, what are the assumptions for the population? Is the sample must be random sample from the population, and the population must be normal, or the sample size must be greater than 30. Okay, so that's the thing that we need to have in the population and the sampling method when you are testing a hypothesis for the mean. Alright, so let us do one example. I will show you both critical value method and the p-value method, or this is also called traditional method. Okay, and then after that I will show you just the p-value method. I will show you how to use R to do the hypothesis testing. Okay guys, alright, so let us do the example. It says the time of sleep, that is the sleep time, okay, for 12 randomly selected adults are, this is the data for the 12 people that have, these are the time of sleep that for those people. Assuming that the variable is normally distributed with alpha equals to 0.05 and population standard deviation is given as 1.9, test the claim that the average amount of sleep for adults is less than 7 hours. Let me list the given things first here, right? Okay, let me list the given things. So what is given there is, number one thing it is given is the data is given, n, the sample size n is 12. This is given, right? And what else is given? Alpha is 0.05. This is also given. 0.05 is given. What is next is sigma is given. The population standard deviation is given as 1.9. Okay. And then is it, what do you think? Is it left tail, right tail, or two tail test? It says less than, right? It says less than 7 hours. So it should be left tail test, right? Left tail test. Okay. So let us write down the null and alternative hypothesis. It says that test the claim that the average amount of sleep for adults is less than 7 hours. That's what you want to test for. Okay. So what we do is, this is for the population. Okay, this is for the whole population. We want to test that the average amount of sleep or average time of sleep is less than 7 hours. So what we do is we assume that it is greater than or equals to 7 hours. That means mu equals to, we write 7, but it is basically greater or equals to. Okay, and you want to test for mu less than 7 hours. Okay, now what is the test value? The formula for the test value, you see that this one, the formula for the test value, if for a mean when the population standard deviation is given is, you write g equals x bar minus mu over sigma over root n. Okay, so what is the x bar? X bar is the sample mean, so you need to find out the mean of those. Okay, how do I find out that? Is you add those and divide by the number of items, number of data, so that is 12. So 4 plus 8 plus 4 plus 4 and so on. I'll add all those and divide by 12. So when I divide, I got 6.83. That's what I got for x bar. So 6.83 minus mu is 7 divided by sigma is, what was our sigma? 1.9. 1.9 and then divide by, I got 1.9 and then divide by n is 12. Root under 12. Okay, that is the test statistic. Okay guys, now I need to use calculator for this, or I can use R for that, right? So if you want to use that in the R, let me do that. 6.83 minus 7 and then divide by, there are two things in the denominator, so I want to start with parenthesis there. So 1.9 divided by square root, okay, of what? 12, right? That's what I got. Okay, so if I hit enter, I got negative 0.3099. That is negative 0.31, right? That's what you got. Negative 0.31. Negative 0.31. So I'm doing this problem by hand, but usually we will use R to do these kind of things, but you need to know how to do that by hand. Okay. Next is I want to find out the p-value method. So this is left tail test, right? For the left tail test, what you want to do is p-value is the area left of the test value. Okay, this is the normal distribution. There is 0 in the middle. Negative 0.31 maybe somewhere here. You see that? Negative 0.31 maybe somewhere here. Now you want to find out the area left of that. That is the p-value. P is the area left of negative 0.31. Do you remember the R syntax for that? So P is to find out the area. What we do is we do P norm, right? P norm, and then the number that you want to find out the area left of, that is negative 0.31, and then mean is What does the population mean? Oh, by the way, you don't have to do the population mean here. This is 0, 1, right? You should do 0, 1. Okay, so the p-value is area left of the test value here, because g is negative 0.31. That's what we found, right? So g is negative 0.31. So whenever we talk about the g, it should be the whenever we talk about the g, it should be the 0 and 1 for the mean and standard deviation. Okay, so if you do that, p norm and negative 0.31 and then 0. So p norm negative 0.31 and then you got 0 and then 1 comma, right? So if you do that, I got 0.1814. That's what you got. So that is 0.1814. This is the p-value method. Okay, now if you want to use the critical value method, so what is alpha? So our alpha is 0.05, right? 0.05. So to find out the critical value method, you want to find out the critical, since this is the left tail, that alpha goes to the left side. Okay, 0 is in the middle. Since it is the left tail test, so alpha goes to the left side. So it is 0.05. Okay, so this is basically this area is 0.05. Okay, you need to find out that z. Okay guys, so how do I find out that z? Since you want to find out the critical value here, we need to use the g equals to, so q norm, because here you are finding the area, so you used p norm. Here I am finding the g, that's why you need to use the q norm. And then what is the left area? Left area is 0.05 and then 0, 1. Okay, so if you do that, what do you get? I think you will get negative 1.64. I think, let me double check. Okay, so q norm, and then you do 0.05, right? And then 0, 1. You see that? So negative 1.64. That's what you got. Okay. Oh, hold on. By the way, I think I made a mistake there. Okay, because so when you do the when you do the p norm, I should do negative 0.31, not 0.91. Okay, so if I do that, let me try that, negative 0.31. Okay, so let me do that. So if I go up, so instead of negative 0.91, it should be negative 0.31, right? So when I do that, I get 0.3782. So this value must be 0.3782. Let me erase that and then write 0.3782. Okay guys, so that should be 0.3782. So see here, how do I make the decision by the p-value method? So is the p-value, what is our alpha? Alpha is 0.05, right? So is p-value greater than alpha or less than alpha? So definitely p-value is greater than alpha, right? So when you make the decision, let me write by this. So since p-value is greater than alpha, we do not reject 80. So if p-value is less than alpha, we reject 80. If p-value is greater than alpha, we do not reject 80. Okay, how about the critical value method? Look at this critical value method. So what is happening here is, what is our test value? Negative 0.31, right? This is test value. Does this test value fall in the shaded region or non-shaded region? What is the value of g alpha? We denote by g alpha. Okay, that is the critical value. G alpha here is negative 1.64. That's what we found here. Is this this test value fall in the shaded region, this region or that region? Definitely this fall here, right? Because negative 0.31 is right of negative 0.16, negative 1.64. So what we can say here is, since test value falls, let's say does not fall in the critical region. What is that critical region? This shaded region is also called critical region. Critical region, we do not reject H sub 0. So this is the method that you see in you saw in statistics class. Okay, we do not reject H sub 0. All right, so what we are going to do here is, I want to write the conclusion. So both method gave the same decision, meaning we do not reject the H 0. So how do I write the conclusion? It is hence Hence, so what is the claim? Claim is this one, right? So the claim is the average sleep is less than 7. So we do not reject means we actually supported that one indirectly, right? Hence there are not enough evidence to support the claim, that average value, average sleep time, I say average sleep time is less than 7 hours, meaning that we do not reject this claim, we do not support this claim. Okay, we do not reject the null hypothesis, so still the average sleep is equals to 7 or greater than 7 hours. That's what we can say from this problem. So those were the two different methods that we use to do by hand. Okay, so from now on I will do most of the problems in R because it is easy and quick, but you need to know how to do by hand, you need to understand the concept, but when you do your homework or the project you can do those kind of hypothesis testing directly in R. Okay guys, so what is the R code? If you want to do by R, what should we do? So first of all we need to write the data. So data equals to C, and then you copy those data points, right? And then you do g.test. So this test is used to test the hypothesis for mean when sigma is known, when the population standard deviation is known. What you do is g.test, and inside the parenthesis write down what data you have, the data, and comma mu equals to 7 is the null hypothesis. Okay, mu equals to 7 is the null hypothesis. Standard deviation is 1.9 is the population standard deviation. Confidence level is 1 minus alpha. That's what the confidence level is, because alpha is 0.05 and confidence level is 0.95 because that is 1 minus alpha, and alternative is less because this example is the left tail test, right? So if you do that and then run, what do you get? Let me go over the R code. This is the data I have. Okay, this is the data I have, and then just run I run that data line, and then I run that g.test. See what I get? I got g equals to, the test value is negative 0.30387, n is 12, there are 12 data set and data points. Standard deviation of the population is given as 1.9. This is the sample, so standard deviation of the sample mean, that's the standard deviation of the sample, that is the standard error actually, and p-value we got is 0.3806. so this p-value is very much close to the p-value we got, right? So still the result does not change, meaning that still this p-value is greater than alpha. Okay, so this p-value is a little bit off from our p-value. It may be because the number of decimals that we consider and the number of decimals that are considered there. Okay, so see, the alternative hypothesis is true mean mu is less than 7, so that is the 95% confidence interval. So since this is the left tail test, it is the one-sided interval. Okay, it is one-sided interval. So I will discuss that a little bit later, but what we see here is this interval, this 95% confidence interval include that true mean, the mu equals to 7 here, right? It is included here, meaning that we do not reject the null hypothesis, meaning if the true value is included in the confidence interval, then we do not reject. If it is not included, then we reject. That's what we get. And what is this thing is the sample mean from the data. Okay, so see, just one click R will test the hypothesis right away. Okay, now what do we see? Since the p-value is greater than alpha, then this is how you write the conclusion. Okay, this is how I want you guys to write in the homework, in the test, in the project, and everywhere. So if as p is greater than alpha, we do not reject the null hypothesis. That's what we got from when we did by hand. So there are not enough evidence to support the claim that the average sleep time of the population is less than 7 hours. Okay, so this is how we do using the R. Let me go over some remarks. Okay, when you reject null hypothesis, the corresponding 1 minus alpha confidence interval does not include the true population parameter. But if you do not reject, then it will include. Okay, look at this. So what is the p-value? We got p-value is greater than alpha, meaning that we do not reject. Do not reject means this population value, the population parameter must fall in that interval. Look at this. So mu equals to 7. Does the 7 fall in negative infinity to 7.73? Yes, because 7 falls in this interval. That's what it is saying, okay? So if the true population value or the true population parameter fall in the confidence interval, then we do not reject, otherwise we reject. That's the way that we can use confidence interval to test the hypothesis. Okay guys, next is when you fail to reject the null hypothesis, the corresponding 1 minus alpha confidence interval includes the true population parameter. That's what I just said. Now let us do one more example. The birth weight of extremely premature babies is normally distributed with population standard deviation is 200 grams. Birth weights of 36 randomly selected premature babies are given below. At alpha equals to 0.05, test whether the average birth weight of the premature babies is different from, so this is two-tailed test, right? Is different from 1610 grams. You want to test whether the average of the population of the premature, average weight of the premature babies in the whole population is equals to 1610 or different from that. That's what you want to test. What you need to do here is you write data equals to C and then you copy that, right? That's what I have done here. That's the same problem. I wrote weight, I gave a name weight. Weight equals to C and then I copied that data, okay, separated by comma. If you cannot fit on one line, you can write the data in the second line. And what I did is I did G dot test is weight, that is the data, comma mu is 1610, that is the null hypothesis, right? Standard deviation 200, that is given, population standard deviation. Confidence interval is 0.05. Why? Because alpha is confidence level is 0.95. Why? Because alpha is 0.05. So confidence level is 1 minus alpha, that is 0.95. Alternative is two-sided, okay? If you run this data and then the G test, you get what? You got the p-value less than alpha. So p-value is less than alpha means we reject the null hypothesis. So what will be the null hypothesis here? The null hypothesis here was, let me clear that first and then, so the null hypothesis here, okay, so what was your H sub 0? So H sub 0 was mu equals to 1610, right? What is H sub 1? H sub 1 as mu not equals to 1610. So what is your p-value? You did that in the R, you got p-value is equals 0.002. I think that's what you got the p-value, right? Let me make sure that. So you got p-value is 0.0024, yes. So 0.0024, that's what you got. That is the p-value. Okay, so you reject the null hypothesis because p-value is less than alpha. So we reject the null hypothesis. Reject the H0, right? That's how you are supposed to answer your question, okay? Just run that code and then find out what the p-value is, and then you say as p-value is less than alpha, in this case we reject the null hypothesis. That is the decision. Now conclusion is there are enough evidence to reject that the average weight of the premature baby is equal to 1610. So we reject that one, okay? So this is how you do the hypothesis testing by using doing by hand and using the R, the software R, okay? Software R is a lot easier. You just write down, just change those values and put the data there, change those values and just find out the p-value. Okay guys, so the next one I want to do is the t-test when sigma is not known. Okay guys, sigma is not known. So when sigma is not known, the step 2, this is the formula to find out the test value. Previously we denoted by what? Previously we denoted by, I don't know what's wrong. Let me delete that. Let me do that again. Delete that. Oh, I don't know. Anyway, so if sigma is not known, then all the steps are exactly the same, okay? Only the difference is you will have to you will have to find out the test value slightly differently. We denote by t instead of, previously we had z, right? And instead of z we'll have t, and we'll have x bar minus mu over s over root n. Why? We don't have sigma over root n there because sigma is not known. So you will find out the sample standard deviation s and divide by the root n in the denominator, okay? And then to find out the p-value, what do? In case of the one-tailed test, I think I mentioned that p-value thing here too. In case of the one-tailed test, you find p-value is the area left of the value, test value. For the right-tailed test, p-value is area right of the test value. So you do p norm and then left area. You do 1 minus p norm because it is the right area, that's why, okay? And then in the two-tailed test, you do p equals to double the area left or double the area right. How do we decide whether it is left or right? Is if the test value is in the left or in the negative, then we do 2 times the p norm, okay? If the p value is positive, then we do 2 times 1 minus p norm. That's what you do, okay? Find the right area and then multiply by 2. So exactly the same idea here for the t test or the hypothesis testing for mean when sigma is not known, okay? This is the test statistic or test value. That's the formula you use. And then p value is, you do pt test value df if it is left tail. For the right tail, you do 1 minus pt test value df. That's for the right tail. And for the two tail, you do 2 times pt. That is if the test value is negative, falls in the left, and 2 times 1 minus pt test value df. See, one of the another different is you need df is the sample size minus 1, n minus 1. That's what you do, okay? So the question here is, the example here is, redo the above sleep and baby weight problem using t-test, assuming that the population standard deviation are not known. So what you do is t.test the data, okay, and then mu equals to what was the mu? On the sleep, mu was 7, right? And then for the baby weight, mu was 1610, right? And the confidence interval, so 95%, 90%, whatever percent is, and alternative is, the first one was left tail, the second one was two tail, okay? I think I have done it here. Let us do that. Test for mean sigma not known. So t-test data, I did not copy the data again because it is already here. So the R, remember that it has stored that data already. So mu equals to 7. So see, instead of g dot test, you have t dot test, and then data comma mu equals to 7, which is the null hypothesis. Confidence level is 95%, and alternative is less. Let us run that. What do you get? You get the p-value is still 3887. So you do not reject the null hypothesis here, okay? See, conclusion is, as p is greater than alpha, we do not reject the null hypothesis. So you write the conclusion based on the question, the same conclusion as we got before. Now for this weight problem, t dot test weight is the data, comma mu is 1610. That is the null hypothesis. You don't need STD. See, what is the difference? You don't need this because we don't know this. The population standard deviation you don't need for the t-test, okay? When the population standard deviation is not given, then you use t dot test and then just use the same code except the standard deviation there. And then when you run this, you got the p-value is very, very small. So you reject the null hypothesis. See, as p is less than alpha, we reject the null hypothesis. So there are enough evidence to reject that the average weight of the premature baby is equal to 1610 grams. Okay, guys. So this is how you use R to find out the to test the hypothesis about the mean when the sigma is given and sigma is not given. So if the data is given, R is a lot easier and straightforward and quick.